Hi, welcome back to the YouTube channel. In today's video, we're going to look at how to find the minimum value of a function on a plane. So this problem is a different flavor from the one that we solved before. This problem, we are looking for the minimum of this particular function, and it has to be on this plane, right? So this is going to be called, this is called a constraint optimization. A constrained optimization problem, right? Because we have to minimize this based on this particular plane, okay? And when we do this, the method that we use to solve this is called Lagrange multiplier. And you're going to see other problems on this channel regarding how to use Lagrange multiplier for such kind of problem. So let's just get right into it. So what is Lagrange multiplier and how can it be applied to this problem? Now, what you have is basically we can reframe this as minimize this function subject to x minus 3y minus 2z equal to 12. So we can reframe the question this way. Now, after you've done this, now how do you apply Lagrange multiplier? It basically says that we need to find, so here's the method, right? It says that we need to find the gradient of this function of f and equate it to the gradient of the constraint, which is, let's call it g. Okay, so let me put it this way. So equate to the gradient of g multiplied by a constant called lambda. And we're going to solve this in terms of x, y, z, and lambda, and try to find what would be the values of what x, y, z. X, y, z in terms of lambda, and that would give us the, then we'll find x, y, z and try to find the minimum value of the particular function. Now, let's apply this to this problem. Now, once you find this, you need to solve it together with g of x, right? So what does that mean in this case? So you need to solve these two simultaneously. Solve simultaneously. And you see how we would apply this. Now, let's just get right into it. So gradient of f is given as what? Derivative. So, right, the partial derivatives with respect to x, y, z is a vector, right, with the partial derivatives, okay? Now, what is this? So when you look at this, derivative of this function with respect to x is just 2x. The other one with respect to y is just 2y, and with respect to z is just 2z. Now, well, let's find gradient of g. Now, gradient of g is something as what? Gx, gy, and gz. As you can see, remember that what? We make our g of x, y, z to be this function, minus 2z minus 12. So you take everything to this side so that g of x, y, z will be equal to 0. Okay? Okay. Now, you can find your derivative, partial derivatives with respect to x, y, and z. With respect to x, is going to be 1 because the derivative of the first term is 1 and the rest will be 0. With respect to y, is going to be minus 3. With respect to z, is going to be minus 2. Okay? And that is it. Now, you need to now solve this simultaneously. So what do I mean by that? So this gradient of f must be equal to lambda gradient of what? G. Now, as well as what? The last one, g of x, y, z. So this g of x, y, z must be equal to 0, right? Equal to 0. So we need to solve these two simultaneously, these two equations. Now let's focus on the first one. So when you compare the components, so the first component on the left-hand side is 2x, and that on the right-hand side will be lambda times 1, which is lambda. For the second component, you have 2y equal to minus 3 lambda, and the third component, 2z, minus 2 equal to minus 2 lambda. Now, what does this give us in terms? You need to now solve x, y, z in terms of lambda. It gives us that what x must be what lambda over 2. Here it gives us that y must be minus 3 lambda over 2. And here z must be minus lambda. Okay. Now that you have this, what's the next step, right? So this is why we have equation 2. We now need to substitute this x, y, z into, so use this and substitute them into this equation 2. So because x is lambda over 2, so we have lambda over 2 minus 3 times y. What is y? Minus 3 lambda over 2. Then minus 2z, z is minus lambda, minus 12 equal to 0. So we need to now solve this for lambda. And once we get lambda, the value for lambda, we now substitute back into this for x, y, z. It's quite, I think it's quite interesting, right, when you look at it. So now let's simplify this. This is lambda over 2 plus 9 lambda over 2 plus 2 lambda minus 12 equal to 0. So you can quickly multiply through by 2. And why am I doing this? So that I can get rid of the fraction. So if I multiply each term by 2, I'll get rid of the fraction. So multiply the first equation. So basically this is what I'm doing. This is what my intentions are. Right? Multiply through by 2 on both left hand side and right hand side. So that will give us lambda plus 9 lambda plus 4 lambda minus 24. This is me expanding the bracket. So what does this now leave us with? So when you add this together, that gives us 14. So I think we have 14 lambda, right? Minus 24 equal to 0. So this means lambda must be equal to 24 over 14, which is dividing by 2, that's 12 over 7. Okay, this is what lambda is. Now we can go back and substitute for x and y, for x, y, z. So let's see. Don't forget, we have this equation here. So x is what? Lambda over 2, which is 12 over 7 divided by 2. That is 12 over 14. So which basically is what? 6 over 7. Now for y, that will be minus 3 over 2 times lambda, which is 12 over 7. So this gives us minus 18 over 7. And for z, we have minus lambda, which is minus 12 over 7. So we have x, y, z. So this point, minus 8 over 7 minus 12 over 7 gives the minimum that we are looking for f of x, y, z. Now, finally, all you need to do is you need to substitute these values in order to get, so we need to substitute these values, these points. So what's the point again? We need to substitute this point into the initial function to find the minimum value of it. So f of x, y, z, the minimum of this will be, you remember it is x squared plus y squared plus z squared. So that will give us 6 over 7 squared plus minus 18 over 7 squared plus minus 12 over 7 squared. Now when you do this, you can literally, so this is all positive. So this is, so 36 over 49 plus whatever this is, 18 square plus 144 over 49. And you kind of add everything together. So that will be 36 plus 18 square plus 144. So when you add the numerator divided by the denominator, that will give you the minimum function, right? Okay, so that solved this particular problem. So you can just quickly do this in your calculator to find the minimum value of the function. So that brings us to the end of the video. I'll be posting more videos of this nature to kind of have a feel for different types of functions and different type of constraints. So stay tuned for the next video. So see you in the next one.